Welcome. This demonstration is brought to you by Digital Den. When it comes to managing Terraform state on AWS, it often feels like a chicken and egg problem. While Terraform empowers you to define and deploy your infrastructure as code, configuring the remote backend on AWS can present a challenge. There are various methods to achieve this goal, each with its unique nuances and complexities. Now, imagine you're just beginning your journey with Terraform, and you've chosen to utilize an S3 bucket and DynamoDB table for efficient state management. Typically, you define your backend configuration like this. However, it makes sense to set up the supporting infrastructure for your S3 bucket, identity and access management groups, and policies with Terraform. The real challenge arises when you want to configure your Terraform backend using Terraform itself while ensuring that your backend state remains tracked by Terraform. It's akin to solving a nested dolls problem within your infrastructure management process. This demo provides a practical solution to this conundrum. Using a bash script, you will deploy AWS backend resources, which consists of the following: a dedicated IAM user for Terraform, an S3 bucket to store the Terraform state, a DynamoDB table for state locking. By employing this approach, you not only simplify the process but also significantly speed up the initialization of your infrastructure with Terraform on a remote state. Here's how the solution works. A bash script automates the setup process for Terraform state management on AWS. It performs the following steps. A custom function checks the exit status of the AWS CLI commands and display an error message if they fail. If any command fails, the script will immediately terminate, preventing further execution. The script creates an IAM user named Terraform user and then attaches the administrator access policy to grant necessary permissions. Please note in the demo you use administrator access for simplicity. Please adjust the permissions according to your specific needs and security requirements, as this approach does not follow the principle of least privilege. The script then generates access and secret access keys for the IAM user, and then exports them to Terraform user access keys.txt. It then creates an S3 bucket named TF Remote Bucket Digital Den in the US East 1 region, and then enables versioning. On line 45 it creates a DynamoDB table named TF Lock Table with specified configurations. It then uses the said command to dynamically replace placeholders in the S3 Policy.json file, adapting the AWS S3 policy to match the actual AWS resources and IAM user created during script execution. And finally, it provides a confirmation message for successful execution, summarizing created resources and exported keys. This script ensures the efficient setup of AWS resources required for Terraform state management, handles errors by terminating the script when necessary, and adapts policies for security and automation. You then execute the bash script before configuring your Terraform backend in the main configuration file. By doing so, you ensure that the AWS backend resources are created before Terraform attempts to use them. Following this, within your Terraform configuration file you specify AWS backend resources, such as the S3 bucket and DynamoDB table. After that, you define the AWS provider and version constraints to ensure compatibility and stability. In the provider block, you specify the AWS provider and the AWS region you want to work with. Finally, you initialize the backend configuration. The Terraform init command initializes providers, downloads plugins, and configures the backend, ensuring Terraform is ready to manage infrastructure resources. Let's get started. Task 1. Preparing your AWS environment. In this task, you will cover the key prerequisites that need to be in place on your local machine before you can proceed. These prerequisites include the AWS CLI with associated credentials, the Terraform CLI, and a tool for JSON processing called JQ. You can effortlessly install these tools by simply clicking the links provided in the video description below. Let's begin by discussing these essential tools in more detail. The AWS CLI is a powerful tool that allows you to interact with AWS services directly from your terminal. To use it, you'll need to have an AWS account, and you should configure your credentials using the AWS CLI. These credentials will authenticate your local machine with your AWS account, enabling you to perform various AWS operations programmatically. Terraform is an infrastructure as code tool used to define and provision infrastructure resources in a declarative way. The Terraform CLI is the command line interface that allows you to create, manage, and modify your infrastructure code. Installing the Terraform CLI is essential for working with Terraform configuration files and deploying infrastructure on AWS. JQ is a lightweight command line tool for processing and manipulating JSON data. When working with AWS and Terraform, you'll often interact with JSON formatted responses and configuration files. JQ makes it easier to parse, filter, and transform this JSON data, simplifying tasks such as extracting specific information or formatting data for further processing. Having these tools properly installed and configured on your local machine is the first step towards building, managing, and optimizing your AWS infrastructure using Terraform. You can check if you have the AWS CLI, Terraform, and JQ installed on your local machine by running a simple command for each. On your local computer, open Visual Studio Code, and then open a new terminal. In the terminal, enter AWS --version, Terraform --version, and JQ --version. If you see version information for all, it means they are installed and available in your terminal, and you can continue. If you get errors or no output, it indicates that they are not installed, and you will need to download and install them to use them in your terminal by simply clicking the links provided in the video description below. Now, begin by creating dedicated project folders and a Terraform configuration file. This is an essential step in organizing and structuring your project. In the terminal, run the make directory command to create a new project folder. Enter mkdir and name the project tf-aws-backend-bash script. Next, access the Explorer panel on the left-hand side. And select Open Folder to browse and select the newly created folder. Now, create another folder in your project's root directory for your AWS bash scripts. Open a new terminal. And in the terminal, run the make directory command to create the AWS scripts folder. Enter mkdir aws-scripts. Create another folder in your project's root directory for your Terraform configuration files. In the terminal, enter mkdir terraform. In the Terraform folder, create a Terraform main configuration file using the touch command. First, change directory into Terraform using the cd command. In the terminal, enter cd terraform. Next, create the Terraform main configuration file using the touch command. Enter touchmain.tf. This will create an empty main.tf file in the Terraform directory. This file typically contains the primary configuration for your infrastructure. It defines the resources, modules, providers, the backend, and other settings needed to create and manage your infrastructure components. In essence, The main.tf file is where you specify what resources you want to create and how they should be configured. Task 2. Creating a custom AWS S3 bucket policy for Terraform permissions. Now that you have your environment set up, the next task is to create an AWS S3 bucket policy that allows Terraform to view, get, and update the state files. Terraform state files are essential for maintaining the current state of your infrastructure and for tracking changes between desired and actual configurations. Terraform state, often referred to as TF state, refers to the JSON file that Terraform maintains to store the current state of your infrastructure. This file is named terraform.state by default, but you can configure Terraform to use a different name and location if needed. Begin by creating an S3 bucket policy. In the terminal, change the directory to the AWS scripts folder using the cd command. First, move up one level in the directory hierarchy, effectively changing your current working directory to the parent directory of the one you were in. Enter cd:::. And then navigate into the AWS scripts directory by entering cd AWS scripts. Create a file named s3policy.json in the AWS scripts directory by using the touch command. Enter touch s3_policy.json. Now, let's define the S3 policy to provide Terraform with the necessary permissions. Open the S3 policy file and head over to the GitHub repository where the S3 policy is stored. The link to the repository can be found in the video description below. Copy the policy to your clipboard and paste it into the S3 policy file. Finally, save the file. The policy contains two statements, allowing list bucket, get object, and put object. However, the placeholders need to be replaced with actual values in your specific AWS environment. Using dynamic replacement, the bash script you create will handle replacing the placeholders, ARN, resource, and key using the said command. This dynamic replacement is helpful because it allows you to use the same policy template for multiple S3 buckets or objects without manually updating the policy file every time. When you change the bucket name or object key in the script, it will automatically update the ARN and resource references in the policy, making it more flexible and easier to manage. With this task completed, you have set the stage for secure and efficient state file management within your AWS infrastructure. Task 3. Creating a bash script to automate the creation of Terraform remote backend resources. Streamlining the initialization of your infrastructure with Terraform on a remote state is essential for efficient operations. While the S3 backend is a preferred choice, configuring it manually often consumes valuable time that could be better spent on other critical tasks. In this task, you will explore an efficient alternative, creating a custom bash script to automate the setup process. The bash script will automate the setup of AWS resources needed for the Terraform remote backend. The script will create the following resources: an IAM user with necessary permissions, an S3 bucket to store the Terraform state, a DynamoDB table for state locking. To get started, create a bash script file. Open a new terminal in the root directory and navigate to the AWS scripts directory using the cd command. Then create a bash file by entering touch tf-backend-resources.sh. Close the terminal and open the empty bash file. A complete script has been prepared for you to use and can be accessed in the demo's GitHub repository. Simply click the link provided in the video description below for easy access. Copy the code to your clipboard and then paste it into the bash file. Save the file and close the Explorer to make more space. Now let's go over the script before we execute it. The bin bash at the beginning of a script is called a shebang or hashbang. When you run a script with a shebang, the operating system knows to use the bash shell to execute the script. This is why you commonly see shebangs at the beginning of bash scripts, as it ensures that the script is executed using the correct shell, even if the user's default shell is different. In scripting or programming tasks, it's essential to handle potential errors gracefully to ensure predictable behavior. In the upcoming section, we define a custom bash function called checkExitStatus. This function accepts an error message as its argument. Within the function, it examines the exit status of the previous command. If the exit status is non-zero, indicating a failure, it echoes the provided error message and exits the script with a status code of 1. This function will be used after executing various AWS CLI commands to capture errors. For example, if the creation of an IAM-user, S3 bucket, or DynamoDB table fails, the script will print an error message and exit with a non-zero status code to indicate an issue. When working with Terraform to manage your AWS infrastructure, it's recommended to create a dedicated IAM-user to ensure the security and control of your infrastructure as code processes. The next section sets a variable user name to the string Terraform user, which will be used as the username for the new IAM user. The script then uses the AWS create user CLI command to create an IAM user with the specified username. The output of this command, which includes information about the newly created user, is then captured in the user response variable. Following the command, the checkExitStatus function is called to check if the AWS IAM create user command was successful. If it failed, the function displays the error message failed to create IAM user. The script then uses the JQ tool to extract the IAM user's ARN from the user response JSON output. JQ with the R flag is used to format the output as a raw string. The script then attaches the AWS Administrator Access Policy to the IAM user, granting it administrative permissions. The AWS IAM Attach User Policy CLI command associates the policy with the specified user. The checkExitStatus function is used to check if the command was successful, and if it failed, it displays the error message failed to attach admin access policy to IAM user. Next, the script creates access and secret access keys for the IAM user using the AWS IAM create access key CLI command. The creds JSON variable stores the JSON response containing the access and secret access keys. The checkExitStatus function is used to check if the command was successful, and if it failed, it displays the error message failed to create access and secret access keys. The following lines extract the access key and secret access key from the creds JSON response using JQ and stores them in the access key and secret key variables, respectively. The script then creates a text file named Terraform user access keys.txt and appends the access key and secret access key to it. The script proceeds to create an S3 bucket named TF Remote Bucket Digital Den in the US East 1 region, using the AWS S3 MB CLI command. Ensure that you substitute the bucket name with a globally unique name. Creating an S3 bucket to store Terraform state ensures proper management, coordination, and tracking of your infrastructure's current state. It is a best practice for working with Terraform in collaborative or production environments to avoid conflicts and maintain consistency. Additionally, the checkExitStatus function is used to check the exit status of the CLI command. If the command fails, it displays an error message and exits the script. The script then enables versioning for the newly created S3 bucket using the AWS S3 API put bucket versioning CLI command. Versioning helps you track changes to objects stored in the bucket over time. The check exit status function is then used to check the exit status of the previous command. If the command fails, it displays an error message and exits the script. Creating a DynamoDB table for state locking is a best practice when working with Terraform, especially in collaborative or production environments. It adds a layer of control and coordination to Terraform operations, enhancing consistency, security, and overall reliability in managing your infrastructure as code. The AWS DynamoDB create table CLI command creates a table. It names the table tflock table. It specifies the table's attributes, including an attribute named lock ID with a data type of string. It defines the key schema for the table, indicating that lock ID is the hash key. It configures provision throughput for the table with read capacity units set to 1 and write capacity units set to 1. Finally, it specifies the AWS region as US East 1 for table creation. The check exit status function is used to check the exit status of the create table command. If the command fails, it displays an error message and exits the script. The next part of the script section utilizes the sed command to dynamically configure an S3 bucket policy for secure Terraform state management. It updates the S3 policy.json file. The placeholders resource, key, and ARN are replaced with specific values using the E option of sed. These values are related to the S3 bucket, Terraform state file, and IAM-user ARN. The updated policy is then saved to a new JSON file named newpolicy.json. The updated policy is then applied to the S3 bucket using AWS S3 API put bucket policy command. And then the new policy.json file is removed. It then checks the exit status of the sed and CLI command using the check exit status function. If either of these commands fails, it displays an error message and exits the script. By using the sed command, it simplifies policy management and enables template reuse for multiple S3 resources, with automatic adaptation of ARNs when modifying names or keys. The final part of the script utilizes the echo command. The echo command in Unix-like operating systems provides confirmation messages for task completion within scripts. The messages serve as valuable feedback. Summarizing the following: the successful creation of resources created in AWS region, US East 1. IAM-user creation. S3 bucket creation with versioning enabled. DynamoDB table creation. Export of access and secret access keys exported to a text file. The script then ends with a confirmation message confirming script execution completed successfully. By following these steps, you can ensure that the AWS resources created by your script are properly configured and available in your AWS account. Once you have prepared and saved your AWS infrastructure provisioning script, it's time to execute it. Open a new terminal, and then navigate to the directory where your script is located, using the cd command. Enter cd and then AWS-scripts. Now, you need to make the script executable. In Unix-like operating systems, scripts are not executable by default for security reasons. You can use the chmod command to change the permissions of the script file to make it executable. In the terminal, enter chmod +x tf-backend-resources.sh. By making the script executable, you are essentially telling the system that it's safe to run the script as a program. Finally, you can execute the script by typing /tf-backend-resources.sh. The / before the script name specifies that you want to execute the script located in the current directory. As the script runs, you will see various messages and progress updates in the terminal. Be patient and allow the script to complete all the specified actions. By following these steps, you successfully executed your AWS infrastructure provisioning script, and created the specified AWS resources required for the Terraform backend. To verify that the AWS resources created by your script were indeed created in your AWS account, you can use the AWS Management Console or AWS CLI. Here's how you can verify the creation of specific resources in the Management Console. To verify an IAM user and policy attached, navigate to the IAM service. Under Users, you should see the IAM user you created. Click on Terraform User to view details. Confirm the user has the administrator access policy attached. To verify a S3 bucket, navigate to the S3 service. You should see the TF remote bucket you created listed there. Click on Properties to confirm that versioning is enabled for the bucket. Click on Permissions to check the bucket policy to verify that it grants the necessary permissions to the newly created IAM user, Terraform user. Verify a DynamoDB table by navigating to the DynamoDB service. Under Tables, you should see the DynamoDB table you created. Confirm that the table exists and the settings match what you specified in your script. If your script successfully created access and secret access keys for the IAM user, you can verify this by checking the output file in the AWS scripts directory in Visual Studio Code, where they were exported to. Please note, if someone gains access to your AWS access keys, it poses a security risk to your AWS resources and account. To mitigate this risk and protect your AWS environment, you should immediately delete and rotate your access keys. Task 4. Setting up Terraform Remote Backend with AWS and defining the AWS provider. In this task you will set up the Terraform backend with AWS S3 for state management and DynamoDB for state locking, while also defining the AWS provider and version constraints. Terraform state, often referred to as TF state, is a crucial component that stores the current state of your infrastructure. By default, it's stored in a file named terraform.tfstate. However, you can customize the state file's name and location based on your needs. To manage Terraform state effectively, you can create a backend configuration within your existing main.tf file. This file specifies where and how Terraform should store its state files, including the backend type and specific settings related to state management. Amazon S3 and DynamoDB provide a robust solution for managing Terraform state effectively. Let's look at the benefits of using Amazon S3 as a backend. Amazon S3 is highly durable and scalable. It ensures that your Terraform state file is stored securely and can handle increased workloads as your infrastructure grows. S3 supports versioning, allowing you to maintain historical versions of your Terraform state. This is useful for auditing, rollback, or recovery purposes. You can set fine-grained access control policies for S3 buckets, ensuring that only authorized users and services can modify or access your state files. Now let's look at the benefits of using DynamoDB for state locking. DynamoDB provides state locking, which prevents concurrent writes to the Terraform state. This ensures that only one process or user can make changes to the infrastructure at a time, preventing conflicts. DynamoDB is a highly available and managed NoSQL database service, making it a reliable choice for state locking. It automatically replicates data across multiple availability zones. DynamoDB scales automatically to handle increased load, ensuring that state locking remains efficient even as the number of users or processes grows. Now that we understand the benefits, let's proceed with the steps to set up Amazon S3 and DynamoDB as Terraform backends. In the Terraform folder, open the existing main.tf file. Next, in the video description below, open the Terraform backend reference link. Copy the Terraform resource block to your clipboard, and then paste it into the main.tf file. The Backend S3 attribute specifies that you want to use Amazon S3 as the backend for storing Terraform state. It specifies the type of backend you are configuring. The bucket attribute specifies the name of the Amazon S3 bucket where Terraform will store its state file. Replace this with the actual name of your S3 bucket. The key attribute defines the path and file name within the S3 bucket where the Terraform state file will be stored. It's recommended to organize your state files within the bucket, and this path helps you do that. The region attribute specifies the AWS region where the S3 bucket is located. This should match the region where you've created the S3 bucket. The DynamoDB table attribute specifies the name of the DynamoDB table that Terraform will use for state locking. By configuring these attributes within the Backend S3 block, you are telling Terraform to use Amazon S3 for storing its state file and DynamoDB for state locking, creating a reliable and scalable infrastructure as code workflow. The Terraform block is used to configure settings related to Terraform itself. Inside this block, you have a required providers block. This block is used to specify the providers that your Terraform configuration depends on. In this case, you're specifying that your configuration requires the AWS provider. Within the required providers block, you define the provider AWS with its source and version constraints. Source specifies the source of the provider. Here, it's set to HashiCorp/AWS, which is the official source for the AWS provider maintained by Hashi Corporation. Version sets a version constraint for the provider. The approximately greater than 5.0 constraint means that Terraform should use any version of the provider that is greater than, or equal to version 5.0, but less than version 6.0. This allows for minor version updates but prevents major version updates that might introduce breaking changes. The provider block configures the AWS provider, which allows Terraform to interact with AWS services. Inside this block, you specify the region attribute, which sets the AWS region where your resources will be provisioned. These configurations ensure that Terraform uses the specified version of the AWS provider and sets the AWS region appropriately for all resources defined in your Terraform configuration. It's an essential part of setting up your Terraform environment to work with AWS. Now, save the main.tf file. With these configurations in place, your main.tf file now includes both the AWS provider and backend settings, providing a complete Terraform setup for your infrastructure deployment. Task 5. Initialising Terraform configuration. Running Terraform init after configuring the backend is a best practice to prepare the Terraform environment for proper operation. It initializes providers, downloads plugins, configures the backend, resolves dependencies, and ensures that Terraform is ready to create, modify, or delete resources in your infrastructure based on the configuration. When you run Terraform init, it sets up Terraform for a specific project in the current directory. To ensure it works on the right project, run it from the Terraform directory. Right-click the Terraform folder and in the drop-down choose Open in Integrated Terminal. In the terminal enter Terraform init. Once the Terraform init command completes successfully, your Terraform environment is fully prepared and configured to work with your infrastructure. You can proceed to create, modify, or delete resources using Terraform based on the configuration you've defined. Using a bash script to deploy AWS Backend resources offers a practical solution for managing Terraform state on AWS. It automates the setup of essential AWS components, including IAM users, S3 buckets, DynamoDB tables, and bucket policies. This streamlines the process, improves security, and ensures infrastructure consistency. In summary, it's an effective way to address the Terraform state management challenge on AWS and optimize your workflow.